that this is one that's just hard knocks, right? You keep getting knocked down, and you're like, God, one of these days I want to be able to, see the punch coming and duck it, or staying on my feet. So this is the checklist that I follow when it comes to handling performance problems. Something's wrong with SQL Server. And the first thing I want to say to everybody who has to keep SQL servers in good operating condition is that you don't want to manage your experience by how much your phone rings, right? When things are great at the office, now a lot of you raised your hands that you're developers. You're not responsible for servers in the same sense that DBAs are. But this applies to you guys too. I was a developer for 6 years before I became a DBA. And what I discovered is that the way the business people think of us is not the way we think of us. The best we can hope for on a good day is benign neglect, right? I'm walking down the hall and I see the head of the audit practice, and he's walking towards me. It's like, things are good. Things have never been better. He's like, hey, Kevin, off he goes. I never have a day like, servers, lowest latency ever, fastest performance ever. Never have a day where he's like, Kevin, hey, high five, man, give me a bro hug. Server's so fast, you rock. It's like, you never get that, right? You the top guy in sales. They give you huge checks, bonuses. It's like drive the fancy cars, right? Us IT people don't get that. But what we do get is blame when things don't go well, right? So if you're managing your user experience by how much the phone rings, you are living in a credibility deficit. Because as soon as they've picked up the phone, they're not just a little bit unhappy about how things are going. They are pissed off. Your credibility has already gone down, right? So if they're saying, I have to call Kevin or Tim or Sam or whoever to get something to happen, they're not happy with you. You're not even in that position of benign neglect. You've lost ground. So one of the big things I learned professionally was I had to change the way I was running my business as a person who kept these systems up and running, or who wrote the code. Because if it wasn't cutting it, that affected my career trajectory in a big way. So we got a problem situation. Hopefully the phone didn't ring. Hopefully you've instituted some monitoring so that you know before your customers know, and you're already fixing a problem before anybody calls you. I'll talk about that a little bit more in a moment. So hopefully you've figured it out without anybody having to call you. But let's say it's the worst case scenario. You've got a customer who's called and they're unhappy. Where do you start? The problem nowadays is that there's a half dozen different places you can get performance information. The question is, can you act upon it effectively? Is it actionable information? And one of the things I came to learn over time is that it's not always actionable. You can spin your wheels, kicking gravel all over the place, and not make any headway whatsoever. Another thing, so there's not necessarily a right or wrong place to start, but there are places that give you much more actionable information much more quickly. Another thing that I learned about building a methodology or a checklist is that the secret of really good checklists is that A, they make sense, and B, they cover all of the stupid stuff, okay? So I'll tell you a story about checklists. There's a great book, if you like to read nonfiction, that reads like fiction. It's got a plot and it's got characters and stuff. There's a great book called The Checklist Manifesto. I encourage you to read it. It's written by one of the top officials of the World Health Organization, WHO. He's also one of the top officials of Harvard's medical school, and he's a world-class surgeon. And they were really intrigued by some data they were finding. Anybody heard of data science? How about business intelligence? You heard of that? Not everybody raised their hand at you. Okay, let's try that again. Who's heard of business intelligence? Okay, this is a business intelligence story, right? They're looking over data from the World Health Outcomes, and they see something really interesting. There's all these hospitals in South Africa and Rwanda, Central Africa, sub-Saharan countries that are having better outcomes, spending maybe dozens or hundreds of dollars per patient than hospitals in the United States that are spending tens of thousands of dollars per patient. And they're like, maybe our data's bad. They went back and checked that. No, the data was right. It wasn't like somebody messed up on a spreadsheet and got a 0 and a decimal place in the wrong spot. The outcomes were better. Well, naturally, the question is, how can they have better outcomes when they have a fraction of our budget? So they went and they looked, and what they discovered was these hospitals, who sometimes didn't, sometimes they had to boil their own sheets to turn them into bandages. That's the kind of budget they were bringing. They used checklists for everything that affected human health. Right? Conversely, in the United States, if a doctor were to walk into the room right now, we would all be pushed against the wall slowly because their ego would begin to fill the room and push. Sorry, anyone here a physician or have a loved one who's a physician? It's a long story. My wife worked at a great Vanderbilt hospital, so some funny stories there. But, doctors go to college just to become a general MD. They go to college longer than we go through K through 12, right? So deservedly, they think highly of their skills. And the answer the AMA has always had to problems is more education, right? If you're not having good enough outcomes, you clearly need to be a specialist in whatever that person's suffering from. Well, what they discovered was, the story was kind of told by another poll, another collection of data from at the yearly gathering of surgeons in the United States, the big professional association just for surgeons. They asked the surgeons, how much do you like to use checklists? And it was 40%-ish, right? I don't like it because I'm the smartest guy in the room. Let's be honest. I'm smarter than you. It's okay. Don't worry. I've got it all under control. On the other hand, when they asked those surgeons, how likely are you to agree to have surgery performed on you by a surgeon not using a checklist? 94% said they would not agree to that. Anybody ever heard of a news story, perhaps, in which someone has discovered a month after surgery that there are 3 clamps still inside their body? That's the stupid stuff, right? That's on the checklist that the World Health Organization puts out. Make sure you take everything out of the patient. That's the stuff that I was missing, right? I was literally messing up on the easy stuff. And so, I figured out over time, the way that this works is there's 2 analogies in my mind. One is a funnel, and we have to figure out, we have to put a lot of stuff in it and see what comes out the bottom. Maybe it's individual resource constraints, maybe it's specific SQL statements, maybe it's, errors of some kind. Or I think a better analogy is a series of sieves. We throw a bunch of gravel, a shovelful, and we shake it in a real wide weave of sieves. We get some big rocks, right? Let's fix those first. And then, if that doesn't fix it, we go to a smaller sieve with a tighter weave, and we shake it again. Now we have small, until finally we get the individual thing that's the problem. So here's my checklist, and I'll come back to this over time. The first thing, there's only one checklist you can do. There's only one shortcut you can do, and it requires advanced preparation. So if you're walking in cold to a problem, it's a server you don't have any knowledge that ever existed until the moment you have to fix it. This used to be something that would drive me crazy. I'd get a call and it'd be like, hi, this is Mary in finance in Boston, and we bought this app 3 years ago. It's been sitting on a Jimmy's desk, and it's not working well. We hear you fix these. I'm like, who are you? What company do you work for? I don't know who you are. But if you have those servers in your purview and you know they exist, then a super powerful way to get ahead of the game, whenever you're doing performance troubleshooting, is to know what's different now after you're getting complaints than beforehand when you weren't. What's different? Right? One of the things I'd always ask my developers, it's like, all right, come in on Monday morning, things aren't working right. I see the servers had a reboot. No one told me that that was a part of the change management schedule. Somebody did something, right? So, all right, which one of you guys changed my server? And we didn't do nothing. Well, I changed one stored procedure that it wasn't important. It's like, really? It had, we created a temp table in the stored procedure. It's like, how many records in there? Well, it was about 40 or 50 in the test. And we look at it, and it's sitting there in TempDB right now with 3.4 million records in it. Right? Everything's gone downhill because TempDB is getting all the I/O attention of that particular. What has changed? So I'll talk about that in a little bit of detail, how you can take control of it. The next question we have to decide, and again, I learned these the hard way. What I used to do is to go look at metrics inside of the server. And what happened was, somewhere down the line, I spent 2 or 3 hours doing this, only to find out I had just wasted my time. Okay? So we're going to follow this kind of set of steps and just explain this in a little bit of detail. So that it's your first, your best, and your only real shortcut. What has changed? And one of the things I didn't get as a developer was that change equals risk. So I used to think of the DBA as being this person who was like thwarting my plans. You know, there's nothing. And, you know, writing code for me was fun. I enjoyed it. There was nothing. It was like Legos. There's nothing I like better than to build my little castle of code, you know, and push it out into production and see it in use. I was like, this is great. And when they said, no, you can't put that out there yet. It hasn't gone through the review board. I'm like, I want my toy out there. And then what was even worse was if it went out, and then, you know, I get a call like the next day, and it's like, well, the totals aren't quite right, so you're going to have to roll it back. And it's like, oh, drats, foiled again, you know, that kind of thing. You know, what's the old, have you ever heard the joke, what did the DBA say to the developer? Doesn't matter, he wasn't listening, right? What did the developer say to the DBA?
Doesn't matter, wasn't listening.
It doesn't matter, the answer's still no. So, you know, we got this kind of difference of opinion about things. But I didn't realize at that time that every time I changed the code, I was endangering the real asset of the company. At that stage of my career, a young man, 20-something years old, I thought the asset was this, you know, $300,000 computer system. That's what I thought the asset was. But later on, when I became a DBA and I experienced the first meltdown of one of our big servers, and this, you know, just a pile of smoking slag, I got the call from the CIO that I expected to, but he didn't ask the question I expected. I thought he was going to say, what happened to my server? You know, this big, expensive thing we invested so much money in. And what he said was, what happened to my data? Can you get it back online? How long will it take? And I was like, bing! I had a new revelation. All this time I thought what was valuable was the stuff we were spending money on. That wasn't the case. The value, the real asset that I was in charge of as a DBA now was that data. That's the real value. So I have to keep an eye on all of this stuff. One of the things I started to do over time was I started to take like a daily dump of the SP configure settings and each of the database options in production databases. And if they ever changed, especially if no one told me, I would investigate. If I ever got a complaint about performance, I would investigate to see if any of that had changed. And then I believe it was SQL Server 2005. Could be wrong about that, but I've been using the SQL Server since before it was a Windows product, so I get kind of mixed up about which version something got introduced. So now there's a feature called DDL triggers, and these are great. So let me just show you a real quick script that you can implement. And this is based on some code written by my buddy Aaron Bertrand, who I work with at SQL Sentry. Oops, wrong one. Let me pull the right one up. Problem is I didn't label these properly, so now I'm going to have to look through all of them and find it. All right. So I've got the reference here in the script. He wrote this for MS SQL tips. Let's see, I believe that's 150. So it's a multi-part set of code. He's got a full, you know, article explaining what to do. So there's a table that you can create for your different events as they happen. So remember what the DDL statements were from our earlier discussion about interleaving DDL and DML? Alter, drop, create, right? Those are the things that instantiate, alter, or get rid of objects, right? So that's another thing I want to know about. Like, did somebody alter a procedure? So here's a little table that we create to store all of the events as they happen. And this is the select state, or the insert based on a select that creates the initial catalog of all the different things that exist in there. In this case, we're just talking about procedures. And then here's what the code looks like for one of these DDL triggers. We tell it, for a particular database, I want you to keep track of, and again, this is just for procedures. You can add this for anything else that you want to, tables, functions, views, all of that. Create, alter, or drop. And then there's two more that you'll want to grab as well. Rename and, rename is the big one, and perhaps schema. Because a schema can affect multiple objects at once. So you tell it, I want you to keep an eye on this and look at the XML data as it is processed, and anytime someone issues one of these statements, you can tell it, basically, keep a tracking record of when it happens, what the schema is, what the object is, and so forth. So you can have basically a running log of any time anyone changes anything. And for me, that was a huge breakthrough because we have some shops are really buttoned down, and you have this rigorous change management process. That's great if you can get there, at least from the standpoint of a DBA. Developers always hated it. I always hated it when I was a developer. But this is also really, really powerful if you're in the kind of shop that doesn't have a rigorous change management system, which is where we were with some of our apps. So some of our servers were owned by some groups that were really conservative, really wanted to control everything. Others were kind of loosey-goosey with it, right? So the dev team, they all had SA passwords, and they'd all be doing crazy stuff all the time. So this was a really powerful way for me to know, at 6:45 p.m., things started to go really bad on this server. I could come back and I could say, well, let me look at everything that happened from 6 to 8 p.m. that night and see what was going on. Was anything new added or changed to the system? And if it was, most of the time, it was because of the changes. If it was fine before and then suddenly started acting poorly, that was my shortcut. All right, so that's your shortcut. Not always able to use it, but sometimes you can.
You talked about performance. What's the overhead on that?
I'm sorry, what was the question?
What's the overhead?
What is the overhead on that? I haven't actually measured it. That's a great question. It's not particularly high. It's about the same as a trace, an X event trace.
But you have to maintain the table for it, right?
Sorry?
You have to maintain the table for the history.
You have to maintain the table? Yes. It's a small number of inserts and so forth happens to that. So it's not very high. Maybe, I'm not sure if it would even register as 1%. It's not going to be a very high amount of overhead. All right. Now, the next thing, and I learned this the hard way, I got complaints of a server's performance, and I went in and started to tweak and see if I could figure out what was the problem. It's like, I got this. I know this server. I've been working with it a long time. I know the workload real well. And it was, in this particular case, when I learned to adopt this as a way of working on my servers, it was a replication error. And if you've ever worked with replication, it's brittle. It breaks pretty easily, and it breaks really hard when it breaks, so it's always a pain in the rear to fix it up. And so I spent quite a lot of time thinking, okay, I'm going to have to drop my subscribers and re-add my subscribers and restart the publication. And just on a hunch, I'd already spent like an hour on this, and just on a hunch, I went and checked. And I went and looked at the Windows logs. I had never really done that before. Having all kinds of DNS errors throwing out all over the place. It's like, wow. I've been going in like a couple times a week and spending an hour fixing this because I thought I knew that replication was a pain in the rear. Turns out, yeah, replication is a pain in the rear when it breaks, but it was breaking a lot more because DNS services were coming in and out, and they were really erratic. I'm like, no. The problem was actually outside of SQL Server. And the problem is, if you always start looking inside a SQL Server, you'll never see that problem that's originating outside of SQL Server. So I always encourage you, if you're experiencing issues, look at Windows to see how it's behaving. If it's throwing hard disk errors or SAN errors or driver errors or network errors, Active Directory, there's a whole host of things outside of SQL Server that could be causing problems. And that's actually one of the weaknesses and simultaneously one of the strengths of SQL Server. Like when I worked on Oracle, every single error message was well documented. big fat book, in the late 80s and early 90s. In SQL Server back in those days, the error message book was thin. And there were oftentimes when you would look up an error that you had gotten, there would be nothing in there except for the text of the error message, which you were looking at on your console. Right? You're like, what the heck? Well, a lot of that was because SQL Server, Oracle at that time ran on 60-some-odd operating systems. Right? So it has to have its own and fully encapsulated error messaging system. It has to have its own fully encapsulating thread scheduling system. How many operating systems does SQL Server run on? Actually runs on one. It's called Windows. SQL Server doesn't have its own thread scheduling system. It has a modified version of Windows, and it integrates very tightly with it. So SQL OS, SQL Server's thread scheduling system, is an outgrowth of the Windows thread scheduling system. SQL Server's error management is an outgrowth of the Windows error management. And so that first error I looked up that I had no documentation for was on resource semaphores. I didn't even know what a semaphore was. I pulled up Webster's dictionary, and it was like, has to do with the flag signaling system and trains. I'm like, how does this relate to computers, right? So I learned, definitely don't ignore what's outside of SQL Server, okay? Because SQL Server relies on a lot more Windows-based systems than most of your other competing database platforms do, okay? Now, here's another thing, too. I encourage you to work smarter and not harder. And that has to do with this warning. When I started, I was an Oracle guy. We had 2 multi-million-dollar Oracle instances. We had 2 Oracle DBAs. I moved over to SQL Server. We had 1 SQL Server DBA, me. We had 1 SQL Server box for about a month and a half. And then we had a half dozen. And by the end of the year, we had 40. So what I did on Oracle worked okay on Oracle. When I managed those systems, I'd come in the morning, I'd check all my cron jobs, which is like SQL Server Agent. I'd check all of, see if any of those failed. I'd check to see if there's any errors, which is fine if it's just you and 1 or 2 or even, half dozen servers. But once I had double digits, I discovered I don't scale very well, right? I'd come in and it'd be getting close to lunch, and I'm like, I haven't even looked at all my servers yet. I don't know how. And then I found out that you don't have to do that. We can actually tell SQL Server to tell us when things go wrong. So I've got it in slides, but I'll hop out and show you in a demo in just a moment. What you want to do is you want to set SQL Server to let you know when there are errors, and it will send you an email or send you a text message. Believe it or not, when you get errors, this is actually, I've learned over many long years of experience, getting an error is actually a good thing, because errors have resolutions. Errors have fixes, right? What is worse is having no idea what you need to fix, because you're still kind of hanging in the wind there, right? You could still be spending hours and hours and hours trying to figure out what's wrong. So if you've got an error message, even if the resolution is really, really painful, like restore to your last good backup, at least that's a fix. What is worse is if you've got some error messages that don't seem to correlate to anything that your complaint center around, or if you don't have error messages, that's actually worse, because now you've got to do a lot more work to get to the smoking gun, the root cause of that problem. So let me show you how to make sure you have SQL Server working for you instead of you working harder yourself. What happens is when we go into Management Studio, if you right-click, most of us are only used to using about this much of the SQL Server agent, just the jobs part, right? There's all these other things that most of us don't use very often. The first thing you need to do is go into the Operators section. I think I have a slide for it here, and you want to create a new operator. This is the individual or group that will get emails and pagers, your SMS text messages, okay? And I also encourage you to have a team name rather than, this is not my name at work or anything. I have seen that in the past, where it'd have a person's name and, it'd be Dwayne, he gets the message. The problem is Dwayne has to go on vacation sometimes, right? Well, he doesn't have to, but we want to keep him there, right? So if you have real person's names, what tends to happen is they get promoted, they leave the company, they go on vacation, no one else ever checks. If you have a team rule, that at least, even if you're the only data person, if the lead developer also has access to this Outlook inbox, or the sysadmin has access to this, if anything ever happens to you, you leave, you want to get a promotion, any of those things, other people know to check this as well. Okay? So what you do is you choose to create a alert. As a minimum, you want to create an alert on severity level, SQL Server event alert, on severity level 18 and higher. 18 is the last of the informational messages. You actually get some information about deadlocks happening at this level. Once you get to level 19, some aspect of SQL Server died in some way. It may not be a very big death. It could be a batch failed to complete successfully, or a transact, some kind of transact SQL thing didn't assign a variable, or something had a unclosed by a delimiter. But once you get into levels like 22 and 23 and 24, all the way up to 25, it starts getting pretty severe. Database marked as suspect, database marked as corrupt, user session was terminated. And so what I do is I'll create those for level 18 through 25. I'll send them to me so I can be notified when they happen. And the good news there is that now I know before, a lot of times, I know before my end users even know there's a problem. I can get in there and fix it. A lot of times they're easy things to fix. And I never, ever suffer from that credibility deficit that I was experiencing beforehand. There is one gap in the armor here, and that is we're using SQL Server to monitor SQL Server. So what happens if the whole server goes down? All right, no messages, right? So do be careful about that. Again, but it's free, right?
Yeah, but
so
at that time you got a different problem.
By that time you have a different problem. That's absolutely right. That's absolutely right. So, I make, the company I work for, we make high-performance monitoring tools and stuff that do way more than this, but at least do the free stuff, right? There is one other kind of neat feature. If you have any kind of restrictions on your environment, you have to enable DB mail, database mail, in order for this to work. And so if you're not able to do that on all of the different servers, one thing you can do is you can go into the advanced settings of SQL Server Agent, Advanced, and you can do event forwarding. So you could have a whole bunch of servers that are not able to do mail, but they could forward their events to another server that does. And so that's how we managed our DMZs. We had a bunch of servers that couldn't send out anywhere, only through one little port in our firewall. So that's how we managed it in those environments. Okay? So work smarter and not harder. Now, again, we're talking about what's the big stuff. The first thing, once you get used to using the Windows event log, the Windows error logs, it just takes a minute. And we spent more time talking about it than you will probably have to expend on it. But that's kind of like, doing the, making sure you follow through on the dumb, easy stuff that gets other people in trouble. Just check the Windows log. Now we move on to the next deeper level. Okay? And this is where we look at wait statistics. Anytime SQL Server spends time waiting, it has a SQL Server 2005 and later. Anyone have earlier versions of SQL Server in production? All right. Feel for you.
Vendor applications.
Sorry?
Vendor applications.
Vendor applications, yeah, those darn vendors. You have to use Perfon pretty much in those situations, or Profiler. I'll show you a little bit more about that as well. So with wait statistics, 2005 and greater, anytime SQL Server isn't able to complete its action, it categorizes that time spent waiting into a general category. And this tells us where our bottlenecks are. SQL Server 2005, it was the first implementation. It only has a couple hundred wait stats. In 2008 and later, there's lots of them. And it's really, really effective for figuring out the general area that you need to focus your attention on. It has this category called preemptive waits, which means something outside of SQL Server. So like if you have link servers to an Oracle box, you can now know that it's a link server connection to your Oracle box. It's, instead of, I don't know, it's somewhere outside of SQL Server. That's what 2005 would do. 2008 will tell you exactly what it is. So just to explain how wait stats work, imagine that your every CPU we have, in an analogy, is a drive-through at your favorite fast food place. And, you know, it can process one person at a time, but lots of people are waiting in line. So when you get your chance to step up to the CPU, you ask for something and they hand it over to you right away, right?
I gotta ask you something, Kevin.
Yes.
Can you go back a slide? This is something, to where the people,
Here?
window is on the passenger side, not the driver's side, or is that a different country?
I think I flipped that around, actually.
You do that on purpose.
I think I flipped that around.
Wow.
Yeah, good catch. Yeah. All right, this is what happens sometimes, right? Something went wrong, either we wrote bad code. In my case, you know, I'm joking around about the SQL vacation, because a vacation for me is never a vacation. I have 7 kids, and fortunately 2 of them are out of the home, but that means I have 5 arguing teenage girls in the back of my car. And so, you know, something happens, right? So inside a SQL Server, each CPU that SQL Server can see, logical or physical, doesn't matter. It is given a scheduler. The scheduler can handle multiple threads, just like the cars stacked up in line. Each user is given a thread that's also called our SPID, right? Set the System Process ID. We get a brief moment on the CPU as soon as we connect for what we asked for. Anytime you are actually sitting on a CPU spinning, your SPID, if you look at SP.who or the system tables to see what's happening, you'll see you have status of running. You'll also notice that there's never more running threads than there are CPUs on the box. There's a couple other statuses that exist. One is runnable. And those that are in the runnable queue have been given all the resources they need except for CPU. So you wanted to do an insert, and so you were given that row-level lock or that table level, whatever that lock was, and all the other resource memory that you needed. You've got everything. You just now need CPU. You're in the runnable queue. That's also called a signal wait, because you're signaling, hey, SQL Server, I'm ready. Just put me in, coach. Ready to play. So that's called a signal wait. All these other kinds of waits that are going on are, you know, just to carry the analogy forward, I'm out of soda, or I'm out of locks, or whatever that might be. What happens is you're asked to step out of the way. You're now in the suspended queue, and SQL Server starts to look for those resources that you're asking for, like, I need to do an update statement. I need an exclusive lock on these 40 records, but 3 other people have locks on some of those records. I have to wait until those locks are released. So they go into the suspended queue. Meanwhile, somebody else who just needed CPU gets to step up behind you and get their processing done. This is all going on in a multi-level, you know, set of cycles. It's like clockwork. It's really, really sophisticated. These kind of waits are called resource waits in the broadest sense. So there's a query I'll show you in just a moment that compares the overall situation of your wait statistics, resource waits versus signal waits. And so, based on what I just told you, if you have a higher amount of signal waits than resource waits, what do you not have enough of? CPU, basically. Yeah. You don't have enough CPU. It's very quick and easy to figure that out. If, on the other hand, you have one of these other, or a combination of these other wait statistics that are very high, that gets you in the general category of where you need to do more refined investigation to find out what the problem is. So there's the main DMV, Dynamic Management View, you're going to want to use is DMOS waiting task. And that's one of the main ones. This shows you by SPID what is being waited on. So if I'm going to do a spot check and see what's happening, don't forget, SPIDs of 50 and less, 52 and less, are almost always system processes, right? That's where you'll see the ghost cleanup. You know, and here's the lazy writer sleep task. So back earlier when we were talking about the plan cache, every time the lazy writer goes to sleep, it starts accumulating wait statistics on, and why do I use those pronouns? On it going to sleep for a while, okay? Anything over 50 or 52 typically is going to be end users or jobs or something like that. There's also another one that, well, let me actually show you in demo. first thing I want to show you is just a broad query about weight statistics. And one of the things about those under 50 is that those are natural parts of SQL Server's behavior. They're like our pulse and our blood pressure and our breathing. So sometimes I'll have people who will say things like, you know, I have really high broker weights on my server, and how do I get rid of those? I'm like, actually, SQL Server uses service broker for its own internal work. So you don't want this, if you see those disappear, you'll be lucky to have a server that's still up and running, right? These are all natural and normal things. So this particular one by Paul Randall has a really nice list of weight statistics that we don't care about. So I want to know about all the weight statistics and how much there is, but I don't want to look at any of the ones that are just part of the natural, normal behavior of SQL Server. There's also a command you can use anytime you want to clear out those weight stats. You can also use this for perf month statistics as well. So let's say it's just you on your development workstation. You just want to do 2 or 3 queries, right? You're going to tune those up, and you want to see what the weight statistics are that are generated by those queries. You could do the SQL perf, the DMOS weight stats, and clear it out. So now all of them are zeroed out. The reason why that's useful is because the weight stats are a running total. They're not the delta between where they are now and where they were a few minutes. So it's an ever-incrementing, ever-growing number. So sometimes you just want to know how much lock weights you've had in the last 5 seconds since you ran. So again, we'll just give this a quick shot. This particular machine, in my case, is doing very little work. You know, it's just barely just the queries that we ran earlier, as well as the monitoring software that I'm running. So the monitoring software does a little bit of tracing, and then there's a write log on the data repository where it writes that. So that's the only thing it's got going on. And the slowest thing on there is that the transaction log is it's not on my SSD, it's on my disk, my hard disk. So those are the 2 weights that it's experiencing. Now, let's see here. Pull this down. And again, I apologize. It'll probably take me another 3 minutes to find the next query I wanted to show you. Okay. Not quite 3 minutes. Next one I wanted to show you was just a basic query to differentiate between signal weights and resource weights. And I can't see this very well, but the signal wait time, let's see, yeah, it's just 16% versus resource weights of 83%. That's a pretty healthy ratio, pretty natural ratio. But that's a real nice, easy shortcut to know if you've got CPU pressure on your SQL server. Okay. All right. Now, let me tell you about a few more weight statistics if you do see these on your top 10 list that you need to be concerned about. So, if we're doing a heavy workload, you're pretty likely to see page latch, and page I/O latch up there. Now, when you look at page I/O latch, that looks like it's cut from the same cloth as the other 2, but it's actually not. These 2, whenever you see this XX, that means it has a suffix that just like what you would expect when you see lock, something related to lock. It could be EX. What does EX do you think stands for with exclusive locks, right? How about SH? What do you think that might be? Shared locks, right, exactly. So if you saw page latch SH, that means SQL Server. Page latch means it's trying to get a latch is a very ephemeral, very, very quick hold on a spot in memory, okay? As opposed to a lock, you know, you think about a latch on a garden gate, you know, it's got that little hook that goes into the little eye hole, you know, very light, you know, a storm could blow it open. Whereas a lock, you turn it, keeps the bad guy, the burglars out, right? So, same kind of thing here. Latches are in memory, very transient, very fast. Locks are slower, more intensive. So page latch means I'm going for something in the data cache. And if it says page lacks SH, you know somebody's trying to do reads, but they're having to wait for that memory in the data cache. If it says page latch EX, they're trying to do or insert, update, delete, maybe a merge statement, maybe a truncate, and they're having to wait. The latch XX, that means the non-data portions of the buffer, or of the cache. And then finally, page IO latch, it looks like it has to do with the others, but it's actually, it means two things. That anytime you see page IO latch, that means the process of bringing data from the storage subsystem up into the cache. So for years, people would look at this and they'd say, oh, clearly I have too slow of a storage subsystem because I've got page IO latch waits. It's actually, that's not a good guess unless you know the workload really, really well, because it indicates a problem on one side or the other. Most of the time, our disk subsystems are slow. Yeah, that's traditionally the bottleneck. But the inverse of that is you may not have enough RAM, right? So you can have great SSDs and still, very high-speed flash, and still see this because you've got a 999 gigabyte database and you've got 16 gigabytes of RAM. So it's constantly having to move stuff back and forth, into RAM, out of RAM, into RAM, out of RAM. And that's why you're seeing this page IO latches. Now it's not lick. LCK is lock. And again, if you see loss of LCK underscore SH, LCK underscore EX, and then there's also mutex LCK underscore M and other things that follow it. Usually, of course, that means we have a locking problem, but usually what that means is you have a coding problem that's causing the locking problem, right? A lot of times we're writing code that's too optimistic in terms of its concurrency. It's not, it's taking too many locks. Maybe the where clauses are not precise enough. So this usually is an indication of code. I need to look at the code there. There's a few things you'll see also for CPU. SOS in this case doesn't mean save our shift. It's an acronym of an acronym, which is something that I think is morally wrong. We should not have acronyms there. It stands for SQL OS, which I mentioned earlier is the thread scheduling component of SQL Server that works hand in hand with Windows. So what this means is I keep trying to get work done on a thread, but I can't get anywhere, so I yield that thread and let another one do some more work. That usually means that it's related to CPU. Or you've got too many users for the given amount of CPU you have. And so it's time slicing across too many people and trying to get too much work done. How about CX packet weights? Anybody know what CX packet weights are?
So we got a bunch of threads that finished their job and one that hasn't. When you spread out and many threads have not finished, or many threads have finished, they're waiting for the other one to finish.
Right. Yeah, so CX packet weights, simple enough, means parallelism, right? If you have a well-tuned system, that is going to be a very natural number or a very natural weight stat to see in your top 10 list. If it's like 8 times higher than any other weight stat, it actually might be pointing to an I/O problem. Well, how so? Well, what can happen is, imagine if you've got a database that's on multiple files. Some of it's on file B, some of it's on file E, some of it's on file F, and then lately we added file G, right? And the SAN admin didn't tell us anything about what these LUNs point to. It turns out G is on a whole different array. That instead of on Fiber Channel, it's on iSCSI. It's slower. Well, when SQL Server splits that query into 4 parts, one for each of those, or 8 parts, it parallelizes it, and it lets the queries go, the parallelized parts of the query go, and it's just waiting for results. 3 of those have already finished, and the last one is on a slower disk array. That registers not as an I/O weight, but as parallelism weight. So be careful. A lot of times people say, oh my gosh, we need to turn off parallelism. You'll see recommendations that say, I set max degrees of parallelism for my server to 1, which I think is terrible advice. Okay?
Tell that to our vendor.
Oh, well, now, SharePoint also makes that recommendation, as I recall. What I prefer to do is to leave max degrees of parallelism set to 0, because that tells SQL Server you can use as many CPUs as you want. There's a separate setting called cost threshold for parallelism, and that default setting is 5, which means if you think a query might take 5 seconds, parallelize it, please. And that is really, really aggressive. SQL Server thinks most queries will take 5 seconds. So instead, I set that number always to 30. Pretty big query, right? I don't want you to parallelize any of the simple stuff. My buddy Brent Ozar lives up in Chicago. He sets it to 60. That's his default setting. It can go all the way up to 120. But so my thought is, do as much parallelism you want, SQL Server, but assure me that this is going to be a big query that could actually benefit from parallelism. So that's cost thresholds for parallelism. I/O bottlenecks show up in the write log, like we saw just a minute ago. Page I/O latches, which I just told you about. Yeah.
So you don't do that whole Newman node calculation, that Microsoft has. You know what I'm talking about.
I do know what you're talking about. So there, if you're running on Newman node, which most servers now that are a release old or a couple years old, they're going to have NUMA. There are some calculations you can do, but I find that it reaches a point of diminishing marginal utility very quickly. So I only go to that level of trouble for my really important high-end systems. I don't use that very often. Yeah. Good question. Another one that shows up a lot is I/O completion. It just means it's having trouble getting your I/Os to finish. So it's waiting on something. Often it's the disk subsystem. Okay. And then there are a few that are outside of SQL Server that are worth mentioning. Network I/O is the big one. OLADB, if you're running on SQL Server 2005, you'll see OLADB show up a lot, and that's because it has no other wait stat for stuff outside of SQL Server. Whereas in 2008 and later, it has lots more wait statistics for things outside of SQL Server. So you can, but for example, in SQL Server 2005, full text search shows up as OLADB. Whereas in 2008 and later, there's a separate set of FT_ wait statistics. Okay. So again, I showed you that query that has the top 10 wait statistics for your particular server. There's a few more that you should be aware of. The resource semaphore I mentioned, that's a signal from Windows that Windows doesn't have enough memory to give SQL Server more. Resource semaphore query compile is we're having trouble throttling, and we're throttling on query compilation. And then that sleeping buffer pool flush is checkpoint. So these are things that relate to how SQL Server is interacting with Windows, primarily. And so something is bubbling up from Windows into the SQL Server and slowing us down. So those are things that are typically fixable when you see those in your wait stats list. Here's a question. One of the wait stats that you might see in your top 10 list is wait for, and it means I have encountered the transact SQL statement, wait for, in code enough for that to show up on my top 10 list. Is that a bottleneck?
No.
It depends, but usually no, right? Because somebody intentionally coded it in there, put it in there on purpose. Where I always investigate further is if it's a really old application or it's a vendor app, because vendors often don't know a lot. They'll market their applications. It runs equally well on Oracle, SQL Server, MySQL, and DB2, which means it runs equally crappy on all of those platforms, right?
Amen.
It does not run well on any of them. So a lot of times they'll put that in there because, or what we used to do a lot up through about SQL Server 6.5 or 7 was the hardware couldn't keep up, right? The disk subsystem, we were cooking with gas if we had a RAID 5 in there. We were like, wow, this is great, so cool. But, it had a read or write latency of, a second, 1,000 milliseconds, really slow stuff. So we would write code that says, process this batch, wait for 2 seconds. Process the next batch, wait for 2 seconds. So what I found happens is that we wrote that in the 6.5 or the 7.0 days, and we pulled it forward. So we're running under compatibility mode. And then we pulled it forward again. And, we changed just the stuff that broke. And then and so it turns out the hardware is amply capable of handling it. It's just that we never updated the code enough. And so we got all these wait fors in there for bad code. Another one, this is not an issue. Whenever you see trace, that means it's internal system stuff, SQL Server checking up on itself. And again, we talked about lazy writing. That's a natural part of SQL Server. So there's a lot of stuff in there that is the natural, normal behavior of SQL Server that might look like they are something we should tune. There are some products that, for specific workloads, I really, really like that focus entirely on wait stats. But that can also be a big limitation. What if the problem's not in SQL Server? No wait stats. Right? What if the problem is caused by an error? Wait stats won't show that. What if the system is actually performing as well as it can? There will always be wait stats, right? So one of the things that I'm kind of pointing out as we go along is this is a process that feeds upon itself. So don't take just one of these things by itself. It leads to other kinds of investigation. For me, well, let me throw this slide up while I'm talking about it. The thing that you want to do is you want to corroborate from multiple sources. It's just like in sports. They don't have one ref that's on the field for everyone. My kid's soccer maybe, that's fine. But if people really care, the idea is I've got to confer with 2 or 3 referees to make sure we all saw the same thing. The wait stats are just one ref on the field, and you don't want to do that with your important SQL Server systems. You want to use the other things that are available to you. Again, you don't have to write this down. You don't have to take a picture of it. If you go to slideshare.net/KKline84. Woohoo, class of 84. Actually, I didn't graduate. I graduated in 85. What happened was when I got my first cell phone from Sprint, it was a Motorola clamshell. You remember those StarTAC? But I got an email address, KKline84, and I'm like, I'm sticking with it. So KKline84 at SlideShare, and all of these slides, including 4 or 5 more slide decks, are up there. So you can download it right now while we're chatting. These are the top 10 ones that have good, easy resolutions. Now, here's my next level of interrogation. Now, I mentioned I'm going to corroborate this. I'm going to call in some extra referees. And I'm going to use perfmon and either profiler or wait stats, depending on the version of SQL Server I'm running. And if you're on SQL Server 2000 or SQL Server 2005, these are still actually probably your best troubleshooting tools. With perfmon, this is the age-old, no matter what version of SQL Server you're on, perfmon will be there. Right? And it's nice, really, really nice. The only problem is it doesn't point to a specific SQL statement. It says you're running at 90% CPU. Well, that's way more than normal, so maybe I should do something about it. You're experiencing 50 deadlocks a second. Whoa, that's not good. So it gives you kind of broad systemic things like that. And this is what it looks like. Anyone not familiar with this kind of interface? You click the plus button to add the different perfmon counters that you want to track. And they appear down here. I was actually a beta tester of this product back in SQL Server 6.0 days when they first came out with it. And one of the things that me and some other people around the world were experiencing is I personally am red-green colorblind. And so it assigns these colors to you as you add new perfmon counters to it. And I couldn't tell, A from B up here. So they added this little button where you can do Control-H to highlight. And so whatever you're sitting on down here, it turns real dark black. So you can see it up above. I'm like, woohoo! Finally, I can see.
Thank you for that, Bob.
I'd do it for anybody. But being colorblind is no fun, believe me. Now, one thing that's neat about SQL Server is that any perfmon counter that is inside of SQL Server, now this first one here is memory. That's a Windows perfmon counter. So it doesn't apply here. But any of the SQL Server perfmon counters I can get without even having to use perfmon because they're in a DMV called DMOS Performance Counters. Strangely named, right? So let me show you that real quick. Like earlier I had mentioned how I had this friend of mine who had a lot of recompiles versus compiles. See if I can find this darn example. So there's perfmon counters for each of those. Take just a moment. Oh, this must be it. Oh, sorry. And I can't find it. Well, they say never to type in a demo, but I'm going to go ahead and do it here. And it would help so much if I could see. So I'll type it here. See what I'm doing. So I'll just do a query of all of the different counters. Now the problem is, if you've ever worked with perfmon, the problem is there are so much that it monitors. So there's what they call the objects, and so one example object might be SQL Server Buffer Manager. And then there are the individual objects, or the counters under that. So there's Buffer Manager, Buffer Cache Hit Ratio, Page Lookups, Free List Stalls. That's actually an important one. So one of the things I did when I was at Quest Software, I'll pull this up and show it. You have to actually email me and ask for this. Is I wrote a poster, but Quest isn't supporting this anymore. This is good up through SQL Server 2008 R2. And let's see. So what this poster does is it goes through all of the different perfmon counters. There's about 72. I worked with mostly with Bob Ward and a little bit with Brent Ozar and a couple other MVPs to put together this list of what are the most important perfmon counters when you're troubleshooting, as well as a rule of thumb number if you don't have anything else to go on. Okay? If you have the time and energy, what you should do is record this to a table and find out what your averages are, right? Because it's only by knowing what's normal for your system that you can know when it's abnormal. Okay? And so there is a blogger named Patrick Keisler. So if you type in Patrick Keisler, that's Keisler, and perfmon, he's written a script from this poster that puts all of this into Transact SQL, puts it into tables, gives you the averages, tells you, if you're out of whack on any of these. And so somebody's done all the work for you and tells you what all of the different perfmon counters that you should investigate are. So yeah, I'm real proud of this. The guys, the men and women who work in the Microsoft CSS group have it up in all their cubicles. So perfmon. Again, this is just some highlights of things that you want to look at. If I could only look at, say, one indication of memory pressure, I'd look at the system processor queue length. If processor queue length is greater than, say, about 12, then I know I have got lots of CPU pressure. Now, again, why would I want to look at the server-wide rather than the SQL server? Why?
The only thing on the processors.
Could be something outside of Windows or outside of SQL Server, right? That's in my experience, that is one of the biggest problems that I have, is somebody else could do something on that server. One of the dev teams might have written a Windows service, and the service had a memory leak, or the service had a CPU problem. So there's lots of things that can cause, or it might have SharePoint on it, heaven forbid. Lots of things can happen there. Here are some I/O and perfmon counters. For example, memory grants pending. This is a great indication of memory pressure inside of SQL Server. So if I see that I have a memory-related wait stat, the next thing I do is I come back and take a look at my perfmon counters to correlate and corroborate that. Because if it doesn't, that means something else is going on, right? If you just rely on the wait statistics, you could get a false positive on that. Some red flags. These are ones that we see as they've been around for, oh, I'm sorry, this is not the red flag. This is mislabeled. These are red flags in the sense of this is a specific error situation. Okay? So I mentioned the compiles versus recompiles. That's a problematic situation, indicates there's something wrong in the way the system was coded. Deadlocks per second, I tend to think of that as being a red flag because there's only 3 things that will terminate a SQL transaction in a natural, normal fashion. Commit, rollback, deadlock. All right? So if your app doesn't have good handling for deadlocks, you could be losing data. Another thing, here's an interesting one that reveals the problem: forwarded records per second. So if you remember on the earlier presentation where I was talking about indexes and how when you build a clustered index, it creates a linked list of one page to the next. Well, what happens if you have a heap, doesn't have a clustered index, but the way the table is designed, a single record could span more than one page. For example, you have multiple columns of bar chart 4000, right? Maybe it's a table that accepts notes. So if the first column is 4000 and the second column is 4000 and the third column is 4000, we're way over that one page. How does SQL Server know to follow along from page to page and keep all that data cohesive when it doesn't have a linked list, doesn't have a clustered index? Well, basically, it can't know unless it goes and creates a shadow clustered index, and that's called a forwarding record, so that it can read through a chain of pages and back through the chain of records. So if you have forwarded records per second at all, that means you've got heaps somewhere. And if you have a high number, over 10, that means you have a real heap, right? And you know where I see it the most often? It's my packaged product. Because they designed it for MySQL, which doesn't care as much as SQL Server does, or they designed it for Oracle, which has clustered indexes, but they mean something entirely different. Clustered index in Oracle says, I want to put 2 indexes right next to each other on the disk subsystem so that when I do a join, the data will be physically close to each other. Doesn't mean anything like that on SQL Server. So this small list right here are things that are problems. I'll give you a little explanation for the problem. Now, the other tool that you're going to want to use for corroboration, correlating a big problem you see in the weight stats to an individual specific piece of code that's causing your problem, is either profiler or profiler or extended events, depending on the version of SQL Server that you're using. However, I always teach profiler these days. Why? There's a few reasons. First of all, analysis services works with profiling. So if you ever use analysis services, you can use it in both places. Another reason is that it's been around a lot longer. A lot more people are at least a little bit familiar with it. They work very similar. There's a nice GUI in the latest release for X events that looks a lot like it. But basically, it's an event-driven system. So it has this process that watches to see what happens, and what you've designated will cause a trigger, an event to fire, and it will record. It has a recording event at that point. So there is one problem with Profiler, especially on the old versions. A couple of you raised your hand that you use SQL 2000. Up through SQL, might not be 2000, I think. Up through a specific version, I forget, either 7 or 2000, SQL Server would actually slow down its activity so that Profiler could keep up and write all your stuff. What a great way for a troubleshooting tool to work, huh? After, I think it was at 2000s when they stopped doing that. So after that, what it would do is it had too much activity happening that you said you wanted to trace and it couldn't, it just skipped stuff. So instead of having a full picture, we have a spotty picture, but at least we've got a picture. The way you get around that is use server-side traces. So everything that Profiler does is through, in the GUI, is actually invoking stored procedures behind the scenes. So if you just run stored procedures without the GUI, it doesn't have that round-trip network latency to your client and back. And so this is much faster. The server-side traces version is much faster than the Profiler. So here's where the secret ingredient comes in. You've got to do both of these together. So with Profiler, what we do is you launch Profiler, you tell it you want to do a trace, and you use one of the templates that it has provided for you, or you can create your own. Standard template is usually good enough. And you're going to save this to a file. Don't save it to a table. That is one of the options it gives you, but save it to a file. Again, I'll show you why. Just a second. You could also alter the template. So right now this is looking for logins and logouts, existing connections, remote procedure calls, and transact SQL statements. You could add additional stuff in there if you wanted to, service broker activity or deadlocks. If you add anything to it, make sure you always capture the start time and the end time. I'll show you why that's so important. And you can also do filtering. So you could say, only do this for TempDB and the user database that I'm worried about. But I encourage you to scope it as much as you can, because the less querying it has to do, the less overhead there is. So let's say we're going to get basically all the SQL statements that start and stop at any given time. And then what is the output that it produces is going to look kind of like this. I completed the SQL batch where I selected a username, I selected user type, I did all kinds of things. Batch completed, somebody logged in, blah, blah, blah. So when we're using perfmon, we save that to a file. When we're using Profiler, we save that to a file, and then we can come back and do analysis. And this is where it gets really cool. You open your Profiler, load in the file of all the profile traces you took, and what was a ghosted out option, you could see it on the list under File. It's grayed out. Once you've loaded a Profiler file in, you will now see that there's a new option that's not grayed out. It says Import Performance Data. So that's where you grab that file of perfmon data. And what it does then is it shows you an overlay of both of them together. So Profiler shows individual SQL statements. Perfmon shows the resource consumption. So I could say, look, everything's kind of low and a little bit clustered up high down here. If I click right here, what's the SQL statement that started right here? And it would jump up to it up here. Or conversely, I could look, and some of the columns you can have are like CPU and I/O. So I could just sort by I/O, and I could say, okay, what's this statement, this SQL statement that has the highest I/O? And it would take me down here to the part on the graph where I could see it's really kicking up and consuming a lot more resources. So this is the really, really powerful way of using the free tools that ship with SQL Server to find out what's the smoking gun. What is the SQL statement that screwed up performance and made everybody miserable, right? Oh, somebody dropped an index right here. What are they doing that in the middle of the day for, right? Well, they thought they were in the dev database, but they were actually connected to production. Has anyone else ever done that? Yes, guilty. I done it. Oh my God, what server am I connected to? All right, so that's a very powerful tool. Another thing you may do from time to time is you may also want to do correlate this against other DMVs, right? So there are lots of DMVs inside of SQL Server that have specific uses and specific applications. I'll just throw these up here very quickly. The thing that I love about our community, though, is ours is a sharing community. People write stuff and put it out there all the time for others to use. So hopefully you haven't had to go and write your own preventative maintenance stuff, for example. Maybe anyone here using Ola Hallengren's scripts? So a quarter of us, yeah. Really, really great stuff. By the way, I know Ola quite well, and it's funny because he sounds like a Viking. He's from Denmark, right? But he's like this tall, and a strong wind will knock the man down. I expected this red-headed guy with braids and a mustache and horn, helmet. He's like, oh, Kevin, Ben, nice to meet you. So, yeah, but a brilliant guy. So lots of different DMVs that you can query for specific things. Like, I want to know DMIO virtual file stats. Like, which of my databases is the busiest? Or I keep telling my boss, the guy with budget, I keep telling that person, I need to put TempDB on a flash storage system because it is so heavily loaded. Well, you could pull up DMIO virtual file stats and prove empirically that it's 5 times busier than the next busiest database, right? Wow, that's pretty powerful stuff. And you don't have to write any of these queries yourself. That's even better. So go to Glenn Berry's blog, SQLperformance.wordpress.com, and look up his diagnostic queries. In fact, if you type in Glenn Berry and you get to SQL diagnostic, SQ, #1 choice right there, every time. I go to a library and check things like that occasionally. It's like, you don't know me from anybody. Glenn Berry, I type in my own name and I just get the actor, Fish Called Wanda. Very disappointing, right? So we can do the same thing with like indexes. Here's something I didn't know for a long time. I can check and see if I have indexes that have never been used. Wow, how powerful is that? Again, we were talking about workload, right? If I've got a read-intensive workload, yes, just...
Isn't that indexes which haven't been used since the last...
Thank you. Okay, so let me clarify. This is the big weakness of DMVs. And you do have to buy a product to get historical context. Okay? So all of the DMVs that we've talked about, all of the perf-mon stats, all of those things are just since the last restart of SQL Server. If you want history and historical context, you basically are going to need to buy something. Or you can write your own, right? I actually used to do that back in the day when I, ran a big shop. And one of the things I discovered is that writing your own is not too terribly challenging. You can set aside some afternoons when you have spare time and you can write something and get it up and running. What's really hard is maintenance, right? So a new version comes out. 3 DMVs change. Oh, right. Now I got to check all that and make sure it works. And then a new version launches. It's like, we're not going to production on there for a long time, but 2 people in our organization do want to go to production. So am I going to take all the time and energy to rewrite that now, or do I wait until I absolutely have it? My time is valuable. I'd rather buy something. That's me. But one thing that is good about these queries, Glenn is meticulous. So not only does he release updates with each new version, he releases updates after every service pack, and he releases updates after every cumulative update, which is one level lower than a service pack. So every time they bundle up a bunch of hot fixes, they probably quarterly, not quite quarterly, they will put out a cumulative update. And so he really stays on top of this all the time, and that is a great source for more information. All right. I have lots of scripts to demo, but I'm not going to do that because we've got families and stuff like that, right, that we want to see. So I'll tell you what, I'm going to keep Enterprise Manager open. If after we wrap up we have questions, I'll be happy to show you any of these scripts. If you want that poster, I'll send along with that my script library, which has about 500 SQL scripts in there. And it includes other people's scripts. So it includes the latest release of Glenn Berry's script library, things like that. So I'll send those to you if you want to email me at KevinKlineMeetingPt2.com. All right, let's wrap up. So your checklist is pretty easy. What's your shortcut? What's changed, right? That takes a lot of work, though, to be able to consistently keep up with what has changed if you don't have a change management process. So I give you a few tips on how to keep track of what's changed. Then, next thing to do, again, it takes just a couple minutes. Is it inside or outside of SQL Server? Am I seeing a lot of Windows errors, network errors, other things associated with something originating outside of SQL Server? I had one person call me one time, they're like, your database is really slow. I'm like, I'm sorry about that. Where are you calling from? They're like, we're in Boston. I was like, what other systems are you seeing this problem on? They're like, well, actually everything. I can't get to anything. I'm like, is it really my database? I didn't say that, but that was my next thought. Well, it turns out that the router had gone down, and it had gone to not a backup router, it had gone to a router on another floor in their building. And so it had a couple extra hops it had to go through to get to anything. Like, how fast does Alta Vista, it was a long time ago, how fast does Alta Vista come up for you? They're like, well, it's not fast either. So is it inside or outside of SQL Server? The next question is it related in any way to an error? Again, I skipped this step many times in the past. You know, I left the clamps inside the patient. And I didn't check my error logs, my Windows error logs, my SQL Server error logs, my SQL Server agent error logs. Just takes a moment to do that. After that, I'm sure it's not something outside of SQL Server. I'm sure it's not an error. Then I'd look at the wait statistics to see what is the bottleneck. You know, is it CPU? Is it memory? Is it I/O? Is it code? Is it bad code? Is it bad design? If I see lots of forwarded records, I know there's a pretty good chance that's kind of the harbinger of doom, right? It means this whole application, the whole database has probably been pretty poorly designed. I probably won't have good indexes or data types or all kinds of other problems. So I look for those wait statistics to get an idea of what category it's in, and then I get the second and the third and the fourth referee by looking at the different perf long counters, the profiler behavior, and possibly additional DMVs to tell me exactly what else is going on. Right? Does that workflow make sense? Each time we get a little bit more specific till we finally get to the end user or the set of queries that are causing the problem. It was always a funny day for me when I would encounter a situation in which the problem was a manager somewhere in the building, a business user, had gotten hold of the password. Do you know what happens next? Does anyone know this story? They're like, I've got Access or I've got Excel, and I'm going to open up a connection to SQL Server and say select star from every table I have access to. And I'll just sort it all out on my desktop.
Don't forget to cross-join it.
Sorry?
Don't forget to cross-join it when you're...
Yeah, and then I'll cross-join everything. Now, of course, once you identify a particular SQL problem, then, you know, remediation comes into play. I'm going to fix it. I'm going to change the code. So rather than take you into a deep dive on that, the agenda kind of promised a break. So it's 4 o'clock. Why don't we take a few minutes break? And if you want to stay, I will show the free tool that we have for query tuning. But I certainly don't expect that from any of you. So if you wanted to head out, feel free. But before you go, I want to take a picture of this awesome-looking crowd. Tell my boss I was actually here. If you grab the T-shirt, do me a favor and pull it out. This is it's gonna make me so happy. All right, you guys are killing it. Okay, ready? Smile. And I'll get Julie. Awesome. Thank you so much. You guys are great. Okay, so let's come back at 10 after 4.
Hey, if you guys can fill out your evaluations, we got the raffle